Basic Logisim tutorial. This presentation is about using Logisim to create simple circuits. Other presentations will address how to make subcircuits to simplify and abstract your circuit, and how to use buses to group bits together into bit strings and split those buses apart to deal with the individual bits. Downloading Logisim. Go to the website indicated in the description of the video and on Blackboard. Download the jar file. Notice that the browser warns you that this type of file might damage your computer. This is because it is an application. You should allow the browser to download the jar file. Although there are installers available for both Windows and Mac, these are out of date. No maintenance has been done on Logisim since 2013, and it still contains some bugs, but it is the best free logic simulator available for our purposes. Once the jar file has downloaded, navigate to your Downloads folder. The file should appear there. Drag it and drop it to an appropriate location where you will be able to access it later. I will place it on my desktop. Putting it in Applications or Program Files will not make it available as a regular application might be. You will have to navigate to it and double-click on it to open the application. Double-click on the jar file to open the Logisim application. In Windows 10 and in many installations of Mac OS X, that is all that is necessary to run Logisim. However, I am using Mac OS X 10.12 with some security options turned on, so the operating system makes me confirm that I do indeed want to run the jar file. When I first double-click on the jar file, it opens a pop-up that says the application cannot be opened because it is from an unidentified developer. Fortunately, I can override this setting. I need to open System Preferences from the Apple menu. Then I need to select Security and Privacy, and I am presented with a button that allows me to open anyway. I can click through, and then I am asked to provide the authentication details of an administrator user. After providing those, the application will open. I will only need to double-click on the jar file icon wherever I have placed it. When I open Logisim, a bug causes an interaction with QuickTime, which I'm using for screen capture, so the screen dims. However, when we see Logisim open, we get a splash screen as it first opens, and then the main screen appears. A tour of the Logisim window. There are 5 major areas of the Logisim window that you will interact with: the menu bar, the toolbar, the components area, the properties area, and finally, most importantly, the canvas area. The canvas area is where you will draw and interact with your logic circuit. You will notice that there is a grid of points. Everything you place in the canvas will snap to the points in this grid, making them easier to connect. In the menu bar, you will mostly use Save, Save As, and Open. Unfortunately, you cannot open a saved Logisim file by simply double-clicking on it in the file browser. You must open Logisim and use the Open menu pick. Furthermore, you need to have a current project open for any of the menu picks to work. So if you close the last project window in a session, you will need to quit Logisim and restart. Use Load to reload a circuit you were working on and saved. The toolbar contains a number of useful tools. The pointer tool allows you to draw or edit your circuit. You will see more about this later. The poke tool allows you to interact with your circuit in order to test it. We will see how to use some of the other tools later. The components area allows you to select the components you want to put in your design. You can choose from a large number of components which are organized into broad categories. You can find most of the ones you're interested in under the Gates category. The Properties area is blank until you select a component. Once you have selected the component, you can change its characteristics by changing some values. We will see more about this later on. Placing components. Adding a component to the design is easy. All you need to do is to find the component in the library and single click on it. Let's select an AND gate. Then you can drag the cursor into the canvas window and you will see that you are dragging an image of that component. You can place it on the canvas by clicking again. Once a component is on the canvas, you can pick it up and move it. When you do so, all its connections will move with it, though this is not very helpful due to the way Logisim draws those connections. Let's add an OR gate to make a more complicated circuit. Notice the little blue tabs protruding from the components. These are its inputs and outputs. Notice that there are 5 inputs for each gate and 1 output. Changing the properties of a component. For our purposes at the moment, we want to use only 2 input gates. This isn't really a problem in Logisim, as it automatically assumes the unused inputs are connected in such a way as to not influence the output, connected to a 1 for an AND gate and connected to 0 for an OR gate. However, for neatness sake, we'd like to change our gates to have only the needed number of inputs. We can select the AND gate by clicking on it, and you can see the properties area is populated with parameters now. The facing property determines the side on which the various connections are to be made. We don't usually want to change this, since by convention gates have their inputs on their left and their outputs on their right. We also see that there is a number of inputs property. If we select this, we get a drop-down menu of potential values. We'll select 2. Then we do the same for the OR gate. Notice that there are only 2 tabs for connecting inputs to now. Adding inputs and outputs. We need to add inputs and outputs to our circuit so we will be able to see what it does. Under input and output, we can see a selection of input and output devices, including a button and an LED. If we were building a real circuit, we might choose to use buttons for the inputs and LEDs for the outputs. However, in Logisims, the buttons are not sticky, so we can depress only one at a time, and this doesn't allow us to check our circuit properly. Instead, we will choose to use pins. We will see more about the use of pins when we look at creating subcircuits. Pins can be found under the wiring category. So we will place 4 pins, 3 inputs, and 1 output. Let's take a look at the properties of the pins we've placed. If we look at an input pin, we can see that it has the property output, which is no, and we have a property 3 state, which is also yes. Logisim's idea of 3-state logic is not a conventional one and is not helpful to us, so we want to change this property to no. This restricts the values that the pins can have to just 1 and 0, and is not allowed the X value for undefined. Let's also label the inputs as A, B, and C. Traditionally, unnamed input pins are given a letter from the starting end of the alphabet. Now let's look at the output pin. The first thing we need to change is its output property to yes. Notice the shape of the pin changes from a square to a circle. We also want to connect the pin from the left-hand side, so we need to change facing to west. Notice that the little tab is now on the left-hand side of the input. Finally, we want to give a name to the pin. Let's call it Y. Traditionally, we use letters from near the finishing end of the alphabet for outputs, but we don't use Z, which has a special meaning in logic design. The label appears to the left of the output, where we'll be putting the wire. So we want to change the label location property to east. Connecting up the circuit. We're finally ready to connect up the circuit. If we use the cursor tool, we can simply click on the tab of an input, then drag the mouse to somewhere on the canvas. Logisim will make one bend in a wire to get us from the starting point to the end point. Typically, we will need more than this, so we can simply drop the wire somewhere on the canvas. Then by clicking again on the end of the wire and dragging, we get another potentially bent wire segment connected to the original one. This allows us to route a wire from where it starts to where it ends. Notice the end of the wire will snap to the grid points on the canvas, making it easy to connect to the right place. Sometimes we want one wire to split in two. You can do this by simply clicking on the place on the wire where you want the connection to go to and dragging away from it. Notice the circle where the wires join. Sometimes we want wires to cross. In that case, we can click and drag to a new wire over an existing one. Notice that there isn't a dot where the wires cross. To move a wire, we can simply click on it and drag it to a new position. Unfortunately, this often results in a very untidy circuit. We are often better off deleting a wire and redrawing it. To delete a wire, we can right-click on the wire, which gives us a drop-down box, which gives us the option of deleting the wire. Notice this only deletes the segment of the wire that we selected, so it's best to get the connections right in the first place. We can move and delete components in the same way. Testing your circuit. By pointing the finger at an input and clicking it, we can cycle its value through the ones available. Notice, since we made the inputs not 3-state, this means they will flip from 0 to 1 and back again. When we poke the input, the value it has now appears in the input pin. This is difficult to read, however the wire connected to the pin will also change color. Dark green indicates 0, light green indicates 1. Now you can try the various input combinations and determine that our circuit functions correctly. Notice that the internal wires also change colors as their values change. This can be useful for finding a problem in our circuit. Getting help. There is a help website available for you that's accessible from the application. Pick the topic you want to read about, and a help window will pop up with that topic in it. The text contains hyperlinks to more details about some of the topics. Conclusion. We've seen how to download and install Logisim, what the various areas of the Logisim window are for, how to make and place components, and change their properties. We've seen how to connect those components to make the circuit we desire, and finally how to test the circuit using the poke tool. Now you're ready to create your first circuits using Logisim. In future videos, we'll see how to make sub-circuits to simplify and abstract your circuit, and how to use buses and splitters to make more complicated circuits with multiple bits bound together to make bit strings.